In today's lesson, we are going to see an introduction to the real-time multiplayer, and we are going to use Photon Engine, a SDK, to implement multiplayer for Unity. First of all, download the progress that we have done so far. I have made some slight changes from the previous lesson, so you need to download it. And first of all, the type of multiplayer that we are going to do is a real-time multiplayer. As examples of real-time multiplayer, you have Fortnite, League of Legends, World of Warcraft, Call of Duty, Battlefield. As examples of non-real-time multiplayer, you could have games based on turns, like mobile games. So we are going to explore real-time multiplayer because other types of multiplayer require backend programming, and we are going only to develop the client, the front end, so we are not going to do anything on the back end. Okay, first of all, let's go to the Unity Asset Store and let's check the Photon package. The Photon package is a paid SDK. Okay, so this is the only purchase I am asking you to do in the whole course. And the reason why I am suggesting you to purchase this asset is because the high demand that there is about this specific package in order to implement real-time multiplayer. In plenty of job offers, you will see that they ask for people with experience in Photon Engine. So I strongly recommend you to purchase it and download it. And from my side, I am not going to include this package in the project. You would have to import when you download the progress that we have done so far in later lessons. You will have to download this asset by yourself because this is a paid asset and I cannot provide it for free. Okay, so now we are going to open it in Unity. Download it and import it. This is in order to use a ID for the multiplayer project that you are setting up. In order to get an ID for that, what you need to do is just to go to the Photon website, create an account, and here you can create rooms, and with each room there is an ID. Okay, so what you are going to do is create a room. The rooms are free to you are not going to pay to get a room. Of course, these free rooms are not ready for a high volume traffic that means thousands of players using the server, but for your particular case, for learning, it's perfect. Okay, so what you need to do is once you have created an account, just to create a new application, specify the name of the application, the script, an optional description, and you would create a new room, a free new room for you to use it. Now we can set the application ID here. Okay, but you can set it anytime. Okay, you can set in here the application ID anytime. You have the option to access through resources, Photon resources, but you also have the option to access through Photon Unity networking, highlight server settings, and you get the reference to the application ID. Due to the complexity that is the multiplayer functionality, most of today's lesson is going to be guided, and we are going just to start by creating the network controller. Okay, you are going to first create a new folder. Okay, so let's go and do it together. The new folder will be on scripts, controllers, networking. And inside this folder, you are going to create the new script, network controller. You are going to edit it. And now this network controller is going to extend from monoBehavior.callbacks. This is the class you need to extend in order to implement your own network functionality. Okay, so you are going to inherit from that class, and you are going to import the Photon library. And the first thing that you are going to do is just to implement, extend the interfaces that this class is offering to you in order to control the network functionality. You can get these interfaces from here. Just click on the link and you can just copy paste, and we can go through all of them just fast. Okay. First of all, you can create a constant right here that will allow you to just get debug log messages. So we are going to first get these log messages. And in case that you don't have in utilities this method, just implement it. So if we go to the utilities, we just create import any missing library from Photon. Okay. This is a getter that for the moment we will leave as empty. So we are going to say, okay, so let's go through all the methods that we are extending in order to handle our network connection. This method connected to master is called when the client is connected to the master server, when it does the first connection, not when it enters the game, when the room is fully created and the game starts. It's just a connection to the master server. On room list update is called when there is any update on the list of rooms created. We need to know about what rooms have been created in order to join any one of them. This is a method that will be called when someone leaves the lobby. This is a method that will be called when you try to create a new room to start a game, multiplayer game, and it fails. This is what will be called when it fails. This is what will be called when you try to join a room and you fail to join. This is the message that you will get the most, that you have successfully joined the room. This is called when you were already in a game room. You were already in the game and you leave the room, you leave the game. Okay. This is a callback that will be called when a new player has entered the room. This is for the player when it has left the room. This is a call that will be performed when the client that was the master of the whole game switches. Initially, it's the first player, the first one that creates the room, the player who is assigned to be the master. But if this player leaves, then the master switches to another player. And finally here, there is on player properties updated. It's a method that usually you are not going to use it too much. It's when the properties of the player has been updated. Okay, so these are the methods that we are going to extend from monobehavior.callbacks, from the class that Photon Engine provides to us in order to manage the connection. So the next thing that we are going to do, we are going to define a constant that will be the name of the room that we are going to create and join. Okay, eventually we will have one player that will create the room and another player that will join the room, and they will use this name in order to identify the room they are going to create or join. Okay, so since I told you this is going to be guided, so what you are going to do right now is just to download these codes, where most of the things that we have been talking about are implemented. Okay, we have the Singleton accessor, the room name, the Photon, the unique network ID. Okay, when you join a room, you will get a unique network ID that will identify each player. Okay, and as I was saying, there will be one of the clients that will be the master. Okay, we will get that information from this property right here, and we are using a getter to offer that information to the outside. The rest are yet to be implemented, and that's what we are going to do now. So first of all, we are going to implement the connect method in order to connect to the lobby of the Photon application ID that we have created. And we are going to do it through this method. Okay, so go ahead, copy it, move it to the codes, place it just right here. And what we are doing here is that Photon Network has the property local player. That is the reference to the local player when you join the lobby. And you can set a nickname once you enter the lobby. That's what we are doing here, setting the nickname that you will use to be identified in the lobby. And we are just getting a random string just to set this name. Eventually, when you develop a full-fledged multiplayer application, of course, you will create all the necessary menus, screens, in order to set up all these things. But what we are going to do here is just to kind of hard code all the necessary to connect two clients in a multiplayer session, in a multiplayer room, in order to test the multiplayer functions. Okay? So we are setting the nickname, and after that we are connecting to the Photon servers. Okay, this will be the first step in the connection process, and the resulting callback should be this one, on connected master. Okay, that will tell us, okay, we have established the connection with the Photon servers correctly. And what we are going to do is just to declare a private member variable that will keep the information about this initial connection with the Photon servers. Okay, so create the private member variable. Okay, and this would tell us that we have established the initial connection with the Photon servers correctly. We are not still yet in the lobby though. So the next thing that we are going to do is now we are going to join the lobby, and we are going to get the list of rooms. Okay, so now you are going to copy paste this method. Okay, just below the unconnected master, and this method, if the player is not already in the lobby, it will connect into the lobby. Okay, and the method you are going to call it just after establishing the connection with the Photon servers. The next step that we are going to do is that for the method on room list update, we are going to retrieve all the list of available rooms, and depending if we have the room we are waiting for or there are no rooms, we will proceed either to create the room or to join that room. Okay, so for the moment, just copy paste the whole thing and replace the extended method on room list update. This method will be called just as a response of when joining the lobby. You would get the call and with the list of available rooms. Just place this private member variable in the section of the variables and we should be good to go. Okay, and what we are doing here is, first of all, that that list of strings will keep the names of all the available rooms. Okay, and what we are doing here is just clearing the list before filling it with all the rooms that we have retrieved from this extended method. Okay, we are just adding the rooms we got. And if we have an existing room with, we suppose that it's the room we have created and we just join it. If there are no rooms, that would mean that we should create the room. So let's start first with the method to create our room. So copy paste this code, place it just below what we have done, and place the private member variable that we have created just in the section of the private member variables, this total number of players. Okay, and what we are doing here in this creator method, we are specifying two parameters: the name of the room. Okay, this is wrong. This is the name of the room, and the total number of players we want for this room. Okay, in the case of this variable is yet to be set up to the number of players. We set the number of players and we proceed to create the room with some options. Okay, the most important option that you should care about is the total number of players that are going to be in the room, the maximum number of players. And with that options, you should use the Photon network method create room with the name of the room and that options. Okay, if we are successful in the creation of the room, we would go directly with the method on joined room. After creating the room, we are joining it. So the callback method that will go after creating the room would be this one. Now let's do the method to join the room. Just copy paste this method and just place it just below the method create room. And what we are doing here is that in this method join room, we have one parameter that is the room name. In the case that this variable is yet to be set up, we just set it in order, just in case that this method is called several times. We want to avoid trying to join several times, so that's why we are doing this, just to avoid that. And if we are in the lobby, we are going to leave the lobby and we are going to use the Photon network method join room with the name of the room to join the room we want. The next thing that we are going to do is to report an event to notify when the connection with the room has been established. Okay, so what you are going to do is just copy and paste this method to replace our current unjoined room. So right here, and what we are doing here is just this method is being called just after we have created the room and joined the room, or we join the room. So this method is called, and what happens here is that our unique network identification, if it has not been previously set. At this moment, we have the ID, and we can get that ID using the property local player from Photon network. So actor number will be the unique identification inside this room, and we set that value, and we proceed to report to the rest of the system that the connection with the room has been established. So we will proceed to create this event in the system event controller, and the system will know that when this event has been reported, the connection with the room has been established successfully. So now we are going back to the GameController script, and we are going to create a new state called connecting. And for this state, you have to include the cases for the change state, the skeleton in the change state, and the skeleton also in the update method. In both cases, you have to create the case for the new case connecting, okay, and create in the game states the new case. The next thing that you are going to do is create a new prefab screen for the new state connecting, and you are going to use the existing prefab loading screen. You are going to unpack it, create a new screen just with the message of loading, okay? And you are going to activate that screen when you are transitioning, changing to the state connecting. Okay, so when you change to the state connecting, then you will create this screen, this new screen, the connecting screen, in the similar way that you did with the load game screen. Finally, in the change states for the connecting case, you are going to call the method that offers the Singleton network controller that we have implemented, connect. So it establishes the connection with the Photon network and joins the lobby. Okay, so go ahead and do it. Okay, and the result should look similar to this. We have created a new state inside the enum type game states connecting, and we have created the skeleton for this new state, both in the change state and in the update. Okay. Next thing that we have done is that we are interested to create the screen of connecting. So we are calling the Singleton screen controller to create the new screen, the connecting screen. So we have gone to the Unity editor, we have unpacked the prefab of loading screen, and we have created the new screen, connecting screen with a new message connecting. Okay, back to the code. In the change state for the case connecting, we are establishing the connection by calling the Singleton and the method we implemented, connect. Now you are going to create two buttons in the menu main screen prefab, one button to play in single player mode and another button to play in multiplayer mode. So you will have to make the necessary changes in the script screen menu main in order to manage these two buttons in order for one to play as a single player and another play as a multiplayer. In the game controller script, you are going also to create a private member variable. M is multiplayer game, set to false initially, and when we press the button in the main menu screen, play multiplayer, the method that you are going to call will be this one, a public method, play multiplayer, that will set that private member variable to true, and will change the state to connecting state. So go ahead and do it. And the result should look similar to this. First of all, in the main menu screen prefab, we have created another button just by duplicating the existing one. And we have named that button as Play Multiplayer. We have also renamed the previous one to Play Single Player Game. And we have changed the text of both buttons to match its function. Okay. Then we have adjusted the position of each button. And then we have gone into the code in the screen menu main. And here we are just getting the button component and listening to the on-click event. And for the on-click event of each button, both button single player and button multiplayer, we are processing each one of them. Okay. We have also renamed the previous name of when pressing the single player button to play single player, and for the callback that will be called when pressing the multiplayer button, we are now calling this play multiplayer method that it's on the game controller. And what we do here is just to set that private member variable that will tell the system, okay, we are working on multiplayer, and it will change to the state connecting. Still in the game controller script, we are going to use the previously created event network connection with room, that was dispatched when the player had fully connected inside the room. When this particular event is dispatched, then we can proceed to change the state to the load game state, so we can start the multiplayer game. So go ahead and do it. So the code should look similar to this. We are just listening the event that is reported when the player has fully connected inside the room, has joined the room, okay? And the game controller just will listen this event and it will change to the load game state. Okay, if we proceed to run the application and press the play button, we should get some log message related with the connection with the room. Okay, let's check what we got in the in the log messages. Okay, so we are getting requesting to join the lobby, creating the room, and here we got a unique network identification, and we dispatch the event so the game can fully load. Now that we have tested the connection for just one player, when there is no room and the player has to create the room and join to it, we need also to test that for an existing room, the next player is going to join to that room. In order to do that, we are going to make a copy of this project into another folder, and we are going to run two Unity instances. Okay, we will have two Unity editors at the same time. One will run first and the second will run after, and the first will create and join the room, and the next one will check in the lobby if there are rooms. It will find that there is an available room and it will join to that room. So what we are going to do now is just to make a copy of the current project. And what we are going to do is, in order to ease the process of moving the changes from one project to the next, because you have to understand that both codes should be the same. Okay, so we need a way to move fast the changes from the original source code to the copy. So what we are going to do next is we are going to create a batch process called copy game files.bat that will be just this single line that will only copy the changes related with the game we are developing. This will be extremely fast, and it will allow us to have two Unity editor instances synchronized so we can properly test anything multiplayer. Okay, so let's go to do it. First of all, just close the editor, save it, and we are going just to make a copy of the current project in the folder clients multiplayer client 1. So we are going to create a folder right here called clients, and inside this folder we are going to create the name multiplayer client 1. Okay, so multiplayer client 1. Okay, so we copy the full project. Okay, and now that we have a copy, we are going to create this batch file that will allow us to move the changes from one side to the other. Okay, so the name of the batch file that we are going to create can be any name, but I am going to choose this one. So create a new file, text document, and change the extension in order to be bad. Okay, now edit this file, and inside here you are going to use this. Okay, what will do this? What will do this is that it will copy the current game folder into this path. Okay, and this path is just our copy, the copy that we have just created of our project, the exactly same folder game. So we are moving, copying the changes from our base project to our copy project. Okay, we need synchronization. We need to have the same code in both instances. This applies to Photon engine, but it will apply to Mirror or any network SDK that you are going to use. Okay, once you have the batch file, just save it. Okay, and we are going to test it. Okay, in order to test it, now we are going to open both Unity editor instances. Okay, I am going to switch to two screens. Okay, I am going to open both Unity editor instances. Okay, so this is one. This is the base project. Okay, let's open the source codes, and we are going to open the copy. Okay, so let's navigate to the copy in here. Okay, this is the copy, and we are going to open it. And we will place this copy on the second screen. It is extremely useful that when you are developing multiplayer games that you could have at least two screens, so you could see in each screen each connected player. But the more screens you have, the better in order to develop multiplayer games. Okay, we have our second Unity instance right here. And what we are going to do is that we are going to test our batch file that it's working properly. So what we are going to do is just to introduce an error. I don't know, just any error, hello world. Save it, check in the base project that, okay, I have the error here. Now on the copy, we still don't have the error, but we are going to run the batch file. Okay, so the batch file, go to the folder, and here just run the batch file, and now go to the other project and check that you get exactly the same error. Okay, so the batch file is working. So now fix the error, save, use the batch file to copy the changes, verify that in both Unity instances there are no compiler errors. Okay, so we are good. So now it's the time to run both Unity instances and check that both Unity instances are connecting to the same room. Okay, so let's do it. Okay, let's go to two screens. In the two instances, let's run first the base project. It doesn't matter which one you run first. Okay, just press play multiplayer, check in the log messages that you have successfully joined the room. Okay, you have created the room and you have successfully joined the room right here. And in the second instance, we are going to join the existing room. We are going to clear the log on the base project, on the first one, and we are going to run the second. And on the first one, we will get a message telling us that a new player has joined the room. So when we press play multiplayer here, as you can see, we got here the callback method on player entered room. That was one of the methods that we could extend in order to control what was going on with the network. One of the methods that Photon was offering to us in order to do that. Okay, so we have detected that the second player has connected, and you cannot see right here, but here the other players has also joined the room. Okay, so our first synchronization connection between two clients has been successful. In the next step of this lesson, we are going to implement a network event system. So now we are going to implement a flexible system to send event messages between different clients connected through the network. In short, we are going to do something similar to the system event controller, but this time these events are going to be transmitted over the network. Okay, so here in the image, instead of our system event controller that was dispatching events between the different elements of the same system in the same machine, now this middleware will be just a network event dispatcher that all the connected clients on the network are going to use in order to dispatch and listen events from the network. So I am going to guide you through all this process of create this network event system. And the first step that we are going to do is just to create this code in the network controller script. We are going to listen for Photon events on the connect method. Okay. And we are going to remove this listener in the onDestroyed method, okay, of the network controller. So we switch to the codes, go to the network controller, and in the connect method, you are going to add this listener, Photon network, networking clients, event receive. And you are going to add the callback function that will be called when we receive a Photon event. Okay, these Photon events are native from Photon. That means that they are provided by the same Photon. That will help us out in the process of doing the whole system. And the other thing that we need to do is that when we destroy the game object, we should remove the listener. Remember that anytime that you need to add a listener, remember always to destroy it because of the memory leaks. Okay, now you can control dot and generate the method on Photon event. Okay, now we are going to receive from the network an event, and we are going to dispatch what we have received from the network. We are going to dispatch this event locally. Okay, so the ones that are interested to listen for that particular event, we are going to send them as a local event. Okay, so for the moment, just copy paste this code and replace on Photon event that we have typed right here. Okay, and I am going to explain. First of all, this constant, just place it on the top, okay, with the other constants. And what we are doing right here is that we are receiving an event from Photon through the parameter, okay, and the event has properties. One of the properties that has the event is the property code. The property code, you can set it's a byte that identifies the type of message that is the event. And well, for our custom events, we are going to use just the number 99 to identify events that are from us. And what we are doing here is just parsing the received event in order to dispatch it locally again. Okay, so what we are doing here is that this event will have a custom data. Okay, and later on we will, when we dispatch the event to the network, you will see how we do it. And this event, this custom data is composed by an array of objects. Okay, if you recall, our system event controller, we just specify the name of the event and an optional array of objects. So we are just trying to do exactly the same right here. We are working with an array of objects. Okay, so the first position of this array, we will use it as the event name message. Okay, the second and the third position, we will use it in relationship if we want to direct the message to any particular client. So we could specify the target network ID. This won't be really used, at least in the code that we are going to do. And for the rest of the data, we will fill this array of objects with the information we are extracting from the Photon event. And finally, we are dispatching this event to anyone who could be listening this event locally in the system. Okay? Okay, so now the next step would be, okay, we need to dispatch locally this event. So we are going to create the functionality in order to dispatch this event. So we can create it right here. We can just our event system. And what we are doing right here is just creating a delegate, and using that delegate we create our own event dispatcher. Okay, so anyone who wants to listen locally any event received from the network will have to listen this event, and in this method dispatch event is the one that we are using to dispatch a received event from the network locally. Finally, we need to send an event to the network. So what we are going to do is this code, we are going to paste it just after the on Photon event. So first of all, these two private variable members, we are going to move them just in the section of the private variable members. Okay. And what we are doing right here is that, okay, now we are interested to send an event to the network, an event that will be later listened by other clients through this listener, through this callback listener that is listening this and dispatching them locally. So we are interested right now to dispatch for any client on the network. Okay, I want to broadcast to send an event through the network. So we are offering to any part of the system this method, this public void, that will receive the name of the event, the network origin ID, the target network ID, and an optional list of parameters. Okay, and with all these parameters, what we are doing is just to create the message that we are going to send through the event. Remember that we were processing that, just an array of objects. So here is where we are creating this array of objects. Okay, and once we allocated memory for this array of objects, we just use it for, well, we just fill it. We fill it with the name of the event, the origin network ID, the target network ID, and with the optional list of parameters. Okay, so now that we have all the data in place, we only need to use what offers Photon to send an event that will receive all the connected clients, and it will be received through here. The callback method will be called. We will identify as a code that belongs to custom messages that we are doing, and we would proceed to parse it and to dispatch it locally. Okay, so that would be the flow. So now that we have our network event system in place, we have been working on that on the network controller, it's time to test it. And we are going to test it in the GameController. So on the change state method, in the game running state, what we are going to do is the next. When we are transitioning to the state game running, and we are running a multiplayer game, we are going to dispatch to the network an event reporting this name of the event network report network ID. And the goal of this event would be just to report our network unique ID. We are just doing a test, a really simple test. And the test that we are doing right now is just telling any other connected client to the network, hey, this is my network ID. So that's what we are going to do. On the change state, when we are changing to the running state, that means that we have successfully connected to the room and we are ready to run in multiplayer. So in that particular moment, we are going to report to send a network event with this name of the event and with the parameter right here of the unique network ID. Okay? So let's go into do it. Go to the codes, to the game controller, and in the change state, in the change to game running state, right here, we are going to just copy paste this code. Okay? So what we are doing here is, okay, we are using our network event controller. We are using the method we implemented to send events through the network. And we need to just to define the constant this time in the network event controller. Okay, so right here, we are going to define our network report network ID. And as a parameters, remember that it has first the name event, second the origin ID, third the target network ID, and finally the list of optional parameters. So in this particular case, we don't necessarily need to specify either of this unique ID and the target ID. I have coded -1 right in the target ID, so we don't care about who is going to be directed. Okay, and for the optional data, we are specifying this information that we got when we were assigned our unique identification ID just when we joined the room. Okay, so the flow would be, okay, transitioning to the game running state, and if it's a multiplayer game, it will dispatch this event. Okay, and this event will be listened by, in this case, it's going to be listened by the same game controller on other clients. So the next step that we are going to do is that in the change state, in the connecting state, we are going to add the listener to listen events that come from the network. Okay, so in this state, when we are changing the state to connecting, that means that we are going to work with a network, and we need to listen the network. Okay, so we need to listen the network, so we are adding a listener to the network event we created. The network event we created that we were using just after we received a Photon event, we parse it in order to dispatch it in the format we wanted, and we dispatch it locally in order for anyone to listen that event. Okay, what we are going to do next is just make sure that we are going to destroy it. Okay, so in the destroy method of the game controller, we are going just to make sure that we are going to destroy it. Now we can implement this method. Okay, control dot, and it will auto generate the callback method that will process that event. Okay, so the final thing that we need to do is just to listen to that particular event, and for the moment we will only display the received information in the debug log console. Okay, so go ahead and listen for the event that we have created. Okay, just right here, and display the debug log message just to know that this event has been resized. Okay, so go ahead and do it. Okay, and the result should look similar to this. We are just checking the name of the event we are retrieving. Okay, if it's the event we are looking for, this one, then we know that okay, this event is going to have one parameter, that it's the information we want, that it's the network ID of the client who is connected in the network. Okay, and this information we are going to display it in that debug log console. So now if we copy the changes to the another copy, we can now proceed to run both instances, and we should get the expected message. Okay, so we press multiplayer right here. Okay, as you can see, even though we are the only ones that we have are in right now in the room, we have also received this event. Okay, our own event we have also received it. That's right. We are dispatching an event, but these events are listened by everyone. So we are also processing the same event that we are reporting. That's fine. Okay, so the next one, we are going to run the other client, press multiply, and as you can see, in both instances we have the yellow message that tell us that the event that we have dispatched when changing the state to the game running state, reporting the network ID, has been properly resized. Okay, so we are good. So let's keep exploring our network event system with another use case. Now we are going to change the game controller state with a network event. Okay, you have to consider that now you have to synchronize at least the game controller states between all the different connected clients. So we need to use our network event system in order to synchronize this state. So the first thing that we are going to do is in the system event controller, we are going to create a new name for an event. Okay, so just copy paste this. Okay, so we have our event network change state. And we are going to listen to this particular event like this. On the network event listener, we are going to process this event just like this, just copy paste, and I am going to explain. Okay, so go to the listener of events, of listener of network events, and right here you are going to paste the code. So we are listening the network event, change state, and the network event change state will have one parameter that will be the state that needs to be changed. Okay. The next thing that we should do is that now we need to implement this change local state. Okay. But before implementing this change local state, we are going to think about the change state method, because now the change state method needs to check when we are dealing with the multiplayer mode. Okay, because when we are dealing with the multiplayer mode, we need to change the state in all the connected clients, not only locally. Okay, so what we are going to do is that in the change state we are going to extend it just like this. Okay? And you are going to move all the previous existing logic that is present right now in the change state. You are going to move it on the change to the new method change local state, a private method that will contain the previous existing code. Okay, so just take the whole code like this, go where the change state is in the code. So let's go to the code, and in the change state, just above the change state, we can paste it like this, and we can just replace the name right here. This is no longer an override. Okay, we keep the call to the base. Okay, and what we have here is that, well, we are still changing the state through the change state. So the entry point to change the state has not changed, is this one. Okay, but now when we are trying to change the state and we are checking that it's a multiplayer game, we are reporting this change state through the network in order for all the connected clients to change their state. But even if we are on the multiplayer game mode, we need to consider that there are some states, of these ones that shouldn't be considered in during the multiplayer. So you should identify which of these states shouldn't be considered to send it through the network. Okay, not all the states are going to use the network change state. So think about how you would do it and try to do it. Okay, and the solution should look similar to this. Neither of these three should be reported over the network. First of all, on the main menu is just the first screen of the application. We still don't know if the player is going to be on multiplayer or single player. The load game state is also particular of each client, and the connecting state the same as the load. It's something particular of each client. So these three states shouldn't be considered in order to dispatch this network event. Okay? The last change that we need to do before testing is that we should avoid changing the state to the same one. Okay? So if the new state that we want to change is the same one, we just return. No need to call again the change state and risking to dispatch this event again and again and again. Okay, so we are going to control that in this case, and since the game starts in the state 0, the state variable starts with the value 0, and the main menu state is also 0. So this would prevent us to transition to the main menu state. So we are going just to set the state to -1. So when we change the state, this would be different. So we would proceed to run the main menu and change locally the state. Okay. So now what you are going to do is that you are going to trigger the change state for the cases for the pause screen, for the game victory screen, and for the game lose screen. Okay, so first of all, save it, copy the changes using the batch file, and test that. First of all, do the test of the pause. Just first run the first client, connect with multiplayer, Now run the second client, connect with multiplayer, and if you press the pause, as you can see, in both customers, we have transition to the pause state. If we press resume, we resume in both clients. Okay, you can try it again. Press pause and resume again. Okay, if you just trigger the winning condition in, you would see that the winning condition has been triggered in both states. Okay, so far so good. In the next step of this lesson, we are going to create network prefabs, and we are going to start with the player. Before proceeding, we have a task to do. We need to convert the player into a prefab. Why? The reason is that right now our player is just created before the network connection is even established. By creating the player after the connection has been established, we will be able to use the Photon engine to synchronize the player across all Unity instances. So what we are going to do is we are going to convert both the player and the UI into prefabs, okay? And we are going to instantiate them in the state game loading. Okay, so the actions that you are going to do both for the player and for the HUD, you are going, first of all, move the main camera outside the player, then convert the player into a prefab and place it in the folder avatars. The next thing that you are going to do is remove the player from the scene. Now, in the GameController script, what you are going to do is just to create a reference, a public member variable that will make a reference to the previously created player prefab, and you are going to set that previous reference, okay? And you are going to instantiate the player prefab in the load game state. Also, you will have to replace all the references in the camera controller that are making reference to the player by accessing through the Singleton GameController instance myPlayer. And for the case of the HUD, you are also going to convert the HUD into a prefab and place it in resources prefabs screens. You are going to remove it from the scene, and you are also going to create a public member variable that will make reference to the previously created UI prefab, and you are going to instantiate this UI just after you have created the player. Okay, because the player has some reference to the UI, you will have to make it after that. And you will have to create some methods in the interface iPlayer to set the HUD. Okay, because the player script needs the game HUD to report information to the user. Okay, so go ahead and do it. and the result should look similar to this. First of all, we have converted both player and the HUD into prefabs, and we have removed them from the scene. Next, we have created the public member variables that will make reference to the two previously created prefabs. Next, on the change state for the load game, we are instantiating first the player prefab and setting the reference to the interface iPlayer, and next we are setting the HUD, okay, because the HUD is going to be needed in the player to display all the information. Okay. Next, in the camera controller, we have just removed the reference to the player, and we are using the Singleton GameController to access to my player to get the necessary information for the camera controller to work. If we run the project, we should get exactly the same behavior as before, but this time we haven't started with the player or the game HUD in the scene. Okay, so the game HUD is working. For the next part, I am going to guide you in order to add all the necessary components to work with Photon multiplayer. First of all, we are going to add the network component to the player. So go to the Unity editor, and for the player prefab, you are going to add two component patterns. The Photon view, that Photon view will give a unique identification for the network, and the Photon transform view. The Photon transform view will allow us to synchronize the transform across the network. Okay, and on observable search, you are going to change from auto to manual. Okay. The next thing that you are going to do in the code, we are going to add an accessor. Okay, so copy this code and go to the avatar. And on the avatar script, we are going to add an accessor just below other getters. Okay. And you are going to import the necessary Photon libraries, control dot, and import using Photon Pun. Okay. This accessor will ask if there is component Photon view, and if there is a component Photon view, it will return a component. So the next thing that we are going to do, we are going back to the GameController script, and here, in the moment that we are instantiating the player, we are going to check if it's a single player game or if it's a multiplayer game. Depending which case, we are going to instantiate the player as always, like this, or instantiate it in the multiplayer way. Okay, so right now you are going just to copy paste this code and replace it like right here. Okay, and import the necessary library with control dot using Photon Pun. Okay, and what we are doing here, okay, we have our private member variable that tell us if we are working or not in multiplayer mode. If we are not working on multiplayer mode, then we instantiate as always the player fab. But if we are working in multiplayer mode, then we need to use the utility of Photon Network instantiate with the path to the prefab. Okay, and this path should always be inside the folder resources. All your prefabs, if you want to use Photon Network in order to instantiate them, you should have all your prefabs inside a folder called resources. It doesn't matter where is this folder, it's up to you to create this folder. And once you have created this folder, you can instantiate using the network, the Photon Network utility. You can instantiate Photon Network prefabs. Okay, in this case we are talking about this one. Just make sure that you don't destroy the set in the HUD. Okay, so in case that you have destroyed right now, like I did, just recover it. So next we are going to create a new method that will replace the way that we were enabling and disabling the 3D model. The reason why we need to do this is because now we have to take into consideration if we are working in multiplayer mode. Okay, so copy paste this code in the avatar script. And in the case that you don't have still the getter is multiplayer game, just go to the game controller and implement this getter. The next will be just to use the method we have just created, and we are going to replace all the code that was enabling and disabling this 3D model. So go to the places where this model was being used. Next, we are going back to the game controller script, and when we detect that the player has been started, we are going to check if it has not been yet assigned, because now in multiplayer mode we are going to have multiple players. Okay, so we are interested that this reference is only for the local player. So what we are going to do is just to check that if it has not been yet assigned, it will be assigned with the first notification we get. So use the code into the game controller script. Finally, you can proceed to use the batch file to copy the files from the base project to the copy project. And once both codes have been synchronized, we should be able to start the game again. Okay, just make sure first to save the scene, so the changes from one place have been properly moved to the other. And as you can see, we are now working in multiplayer mode for both player prefabs. Okay, so we are able to move the transform and rotate the transform for both instances. Okay, as you may have noticed, the animations were not working, so we are going to fix that now. And we are going to use our network event system in order to change the animations of the avatars over the network. Okay, so the first thing that we are going to do is just to create a new event in the system event controller that will be called event network avatar new animation. Okay, so go to the code, to the system event controller, and in here create a new event. And on the avatar script, you are going to add a listener to listen for the network events, okay? Because we are interested that all the instances across the network of the avatars can listen for this particular event, okay? So on the start method of the avatar, you are going to add the listener only if we are working in multiplayer mode. And as I have told you several times, after adding a listener, you should code to remove it. And here we are going to remove the network event listener. We are also going to take this opportunity that we are on the destruction process to destroy the network object. Okay, so first of all, we have to make sure that we are this is a network object. So photon view, if photon view is different from null, so we have the photon component, and we check if the photon component is mine. Okay, that means that all the network objects have someone who is the owner, and only the owner can destroy their own items. Okay, so we have to check for that. Once we are allowed to destroy the objects, we call the photon network destroy with the photon view. Finally, we implement the on network events, and in here we are going to listen to the event that we are creating. Okay, so just copy paste the code. And here we are listening the events, checking if this avatar has the component photon view. And if it has it, it compares the ID, the network ID of this component with the data from the event. If it matches, if it's the same, we change the animation locally. Okay, when we're sending the event, we are providing two parameters. One parameter that is the network identification of this avatar, and the second parameter is the animation that this avatar should change to. Before continuing, we should fix something that we have done right here. And what we have done right here is just to declare a virtual method onDestroyed. This onDestroyed is also being used in different places that inherit from avatar. Okay, so now what you should do is just to, for all the classes that are inheriting from avatar, you are going to extend that classes. Okay, so just extend all the methods onDestroyed for all the classes that inherit from avatar in order that we don't miss any onDestroyed method. Now we have to modify our existing change animation in order to consider when we are on a multiplayer game. If it's a multiplayer game, then we send this event with the information that I have told you. But if it's not multiplayer, we just change the animation locally as always. Take as a reference what we did with the change state in the game controller, and go ahead and do it. And the code should look similar to this. What we have done is just to move the existing logic to a new method, a new private method, change local animation, where we are changing locally the current animation. And on our method change animation, now we are considering that we check if it's a multiplayer game, and if it's a multiplayer game and this avatar is the owner of the network object, we dispatch the network event reporting the new animation we should change to. Okay, if it's not the owner, or if it's not a network game, then we change the animation locally as always. Okay, so now it's the time to move the changes with the batch file. Okay, so make sure that both scene and code have been saved, and move the changes. And now when you test, you should see the animations running. Okay, as you can see, we are transitioning from running to idle to jump. Okay, for both clients, for this one and for the other. Okay, so our network animation system is working. So in the next step, we are going to do some preparations in order to convert to network objects at least one new enemy. Right now, we cannot easily convert the existing enemies that are on the level prefabs to network objects. Okay, we will need to create a new enemy prefab that we will be able to create during runtime. And we will call this enemy enemy spawn. To this enemy, we will have to remove all the components except the component enemy, rotate to target, and the component navigation. Also, you have to make sure that the component activate wait is set to true. So let's do it together. So what we are going to do is just to create a new enemy. We will take as a reference the enemy 5. Okay. So drag it to the scene, unpack it completely, and rename it to enemy spawn. Okay. Just make sure that this enemy spawn has the property activate wait activated, and it has only the components enemy, rotate to target, and navigation. Okay, so now you can move it to the folder resources prefabs avatars. Okay, and the next step that we are going to do is we are going to create a new script called enemy spawner that will spawn enemies. Okay. This script we are going to create it on the script controllers game. Okay, so right here you are going to create this script. Okay, so the script enemy spawner, and this script will have 3 public members. Okay, that are going to be these ones. It will have a reference to an enemy prefab that we will instantiate. It will have a reference to a game object that will define the origin position that it's going to be created this enemy. And we have a target position that the enemy should go to. And this frequency value is how much time it should pass for the next enemy to be generated. Okay? So go ahead and implement this class following the instructions I have told you. And the enemy spawner script could look like this. What we have done is just in the start method, we are getting the positions of both game objects, origin and target, and we are storing them into private member variables. After that, we can destroy that 2 objects, and we set up a private member variable that we will use to keep track of the time that has passed in order to create the enemies in the frequency desired. Okay, we have created a public method called update logic that it will just increase this time, and every time we go above the frequency, we just reset the time and create new enemy instance. Okay, I have not explained this one, but the idea of this spawner is to create enemies who are going to be given instructions to go to a target position. So for those of you that find out by yourself that you should give the command move to the enemy, kudos for you. But since I haven't told you that, I am telling this right now. Okay, so we set the position origin in the origin, and we use the command move to move the enemy to the target to a certain speed. Finally, we add the command. So now we have to consider this enemy spawner inside our level controller script. And what we are going to do is that we are going to do some changes in the level controller script to consider this enemy spawner. The first one that we are going to do is just to create a private array of enemy spawners. Okay, so let's go to the code and let's do it together. Okay, so in the level controller, we are going to create an array of enemy spawners, and we are going to initialize this array just in the start method. In the start method, we are going to look for all the existing enemy spawners in the scene, and we are going to fill this array. Okay. Next, we have to call for each enemy spawner to its method update logic. Okay, so we have to go through in our update logic method of the level controller. We go through all the enemy spawners, updating their logic so they can create these enemies. Okay, finally, you should destroy these enemy spawners in the destroy method. Okay, so consider to destroy them. And the next thing that we are going to do is we are going to extend the behavior of the command move to. Okay, and we are going to add to this command an additional optional parameter. Okay, so that will be this one, destroy on target. Okay, so go to the command move to, and in the constructor you are going to add this optional parameter, and you are going to create a private member variable that will store this optional parameter. So the way that we are going to use this optional parameter is to report when the command has finished. And we are going to report an event when the command has finished, just in when we detect that the command has finished, that is right here. So right here, if this is true, we should dispatch an event that you are going to create just right now. Okay, this event avatar destroy, you are going to create it on the system event controller, and you are going to add it right here. And what will happen is that when this command move to has finished and this is true, it will report to destroy the avatar. What will happen next is that we are going to remove the existing avatar from the list of enemies, okay, in the level controller. So in the level controller, what you should do, you can copy paste this whole thing. So go to the level controller, and on the system events, you are going to add a new entry. And what will happen here, first of all, import the library using system link queue. Okay, I take this opportunity also to introduce to the link queue libraries. The link queue libraries are a collection of libraries that allow us to perform some iterative operations with a kind of operators that are similar to SQL instructions. So feel free to explore it by your own. But what we are doing just right here is just we are looking for a particular avatar, and we are returning that particular avatar. Okay, if we found it. Once found the avatar, we can proceed to destroy it. Before continuing, we need to fix something that I have detected that later can cause problems. So what you are going to do now is that you are going to download all these files that are related to the commands, and you are going to replace them, okay, in your project. So go ahead, download these files and replace the commands that are these ones, okay? So these commands are the ones that you should replace with all the links right here. So go ahead and do it. So now we can go back to the Unity editor, and we are going to add an empty game object on the level 0. We are going to rename it enemy spawner and attach the enemy spawner script and initialize its values. We are going to initialize its values with an origin position and a target position in a way that the enemies that are going to be generated will have to go through all the labyrinth. We are interested that they navigate through all the labyrinth. Okay, so let's do that together. So let's go to the Unity editor, let's go to the level, and in the section of enemies, we can create a new empty game object called enemy spawner. And we can add the script enemy spawner. And here we can set the enemy we created before, enemy spawned, and we can create a couple of positions for the starting and the ending position. Okay, so okay, so we have our enemy spawner in place, and the enemies will originate in this position right here, and they will navigate through all the labyrinth to the ending position right there. Okay, but the final step that we need to do is that we need to add the newly created enemies inside the level controller in order for the level controller to run the logic related with the enemies. Okay, the new enemies need to be in this list in order to perform its logic. So what you are going to do, what is necessary for the new enemies to be included in this list. So go ahead and do it. Okay, and the solution should look similar to this. What we have done, we have created a new event called enemy has been started. And what we are doing is dispatching this event in the start method of the enemy script. Okay, so when the enemy has been started, we dispatch this event, and this event is going to be listened by the level controller. Okay, and when the level controller listens this event, we'll get the parameter that it's the enemy, and if the enemy is not contained in the list of enemies, it will add it. Okay, we have also created another event in the case that we wanted to create in runtime NPCs, but right now we are not creating any NPCs in runtime, so for the moment we are not going to do anything else with this event. So one last change that we need to do before proceeding is that in the enemy spawner, when we are creating the command, remember that we have created the extra additional parameter, destroy on target, that by default is false, so we are going to set it to true. Okay, and what will happen is that when the enemy goes and reaches the target, it will be destroyed. Okay, so if we proceed to run, what we should get is the enemy going towards the target, and when it reaches the target, it is destroyed. And every 5 seconds, a new enemy is being created. Okay, so far so good. So now that we have at least one enemy that we can create in runtime, we can use that same enemy to convert it to a network prefab. Okay, as I was saying, the existing enemies in the current level prefabs cannot be easily converted to network prefabs because we need to use Photon network instantiate in order to create a network object. Okay, and the enemies and NPCs that are on the level are not being created like this. So that's why we have created our enemy spawn, and we are going to work in this prefab. Okay, so let's do it together. Let's go to the code. Okay, and in here we are going to select our enemy spawn prefab. Okay, and here we are going to add two components: the Photon view that will assign a network identification to this unit, and the Photon transform that will allow us to synchronize the Photon transform through the network. The next thing that we are going to do is that in the level controller script, we are going only to run the enemy spawner only on the master client. Okay, so let's go to level controller, and in here we need to check. First of all, we need to check if we are working in multiplayer mode. So the controller instance is multiplayer mode. Okay, we will create a Boolean variable that should run a spawner to false. Okay, if it's not a multiplayer game, then this would be true. And if it's not, if it's a multiplayer game, then we should check if this is the master client. How we can check if this client is the master client? When we were working on our network controller, we created this this getter is server. Okay, if you go to the is server, you will see that we are driving the property is master client from Photon network. What tells us this property is that each room will have a client that will be the master of the whole room. Okay, it will be in charge of the execution of certain functionalities in order to synchronize all the connected clients. Okay, the concept master, I think that everybody can understand what it means. So what we are doing right here is, okay, if we are on the master, we can proceed to run the spanner. If we are not on the master, we shouldn't run the spanner. So right here, we check the variable, and if it's true, we will run the spawner. Okay? Now on the enemy spawner, we have to take into consideration when we are working in multiplayer, because when we are going to work in multiplayer, we need to create instances of this prefab using the Photon functionality to create network instances. Okay, so what we are going to do here is just to, first of all, check if this is a multiplayer game. Okay, so we check if this is a multiplayer game. And if this is a multiplayer game, we proceed as always. Okay, so let's put this right here. And if this is not a multiplayer game, then we will proceed as always. But if this is a multiplayer game, what we should do is to use the Photon network functionality in order to instantiate the enemy as a network object. So we have to specify the path to that particular enemy. Okay? Just copy paste the same properties that you were using for the player. Go to this right here and copy the properties. And from this game object, we can retrieve the component enemy that we will assign to the enemy. So now, for the enemy spawner, when we are not working in multiplayer, we instantiate the enemy as always, but when we are working in multiplayer, then we instantiate the enemy through the path to the resources. Remember that you should have the prefab that you want to instantiate over the network in the resources folder. So resources, prefabs, avatars, and we are instantiating this one right here. So that's what we are doing right here, just setting the path to that name of that enemy and instantiating it over the network, okay? With origin position and some default values. The final thing that we should do before testing is to avoid running the logic of the enemy script in the case that we are not the owner. Okay, so we are going to paste this code in the enemy script in the update logic, and what we are doing here is that in the case that we are working in multiplayer and I am not the owner of the enemy in the network, the logic of this enemy shouldn't run. Now we can proceed to copy all the changes with our batch script. We can run both Unity instances. Okay. As you can see, it's true that in both instances it's being created the enemy, but we don't have a good synchronization with the animations. Okay, so we are going to try to fix that. So in order for the enemy to start with the animation synchronized, when the Photon created the replica of the enemy on the other clients, what we are going to do is to ask about what is the current animation to the owner of the enemy. And we are going to do that just by creating a new event, and we are going to dispatch the event in the start method of the enemy, okay? And this network event will be listened by the enemy who is the owner, okay? And it will reply to this event just by refreshing the current animation. So go ahead and do it. Okay, and the result should look similar to this. What we have first done is just to dispatch the event on the start method. Since the component Photon view belongs to the avatar, we are dispatching at this level the event requesting to update the current animation. So right here in the start method of the avatar, we are sending the network event to ask to the owner of this avatar about the current animation. And we are requesting that information just after a short delay, because we need to give some time to the network to properly initialize the element. Okay, once we have dispatched the event, the owner of the event will listen, and it will identify the network ID. It will identify that this avatar is his avatar, and it will report the animation through the animation event. Okay, if everything is right and we proceed to run, we are going to copy the changes with our batch file. We run one instance and the other. Okay, so now as you can see, we have both Unity instances synchronized with the right animations. Okay, so now we are going to do the final exercise of this lesson. And what we are going to do is to use our network events in order to shoot bullets across the network. Okay, so what you are going to do is, first of all, create a new event, event network player bullet shot. Okay, that will be dispatched on the player script when running in network mode. Okay, and as a parameters of this event, you would provide all the necessary information for the bullet to run, the position, the forward direction, whatever you consider. And also in the same player script, it will listen for this event, and since this event will be received by all the connected players, when you receive the event, you would proceed to shoot the bullet. Okay, so go ahead and do it. And the code should look similar to this. What we have first done is in the method shoot bullet. Okay, we are just considering when it's not a multiplayer game, then we shoot the bullet as we did before. Okay, but if it's multiplayer and I am the owner of the player, then I proceed to send the event that will be listened by all connected clients. Okay, so I send the event, I provide the network identification for this player, the position of the bullet, the direction of the bullet, and this is going to be received by all the connected clients in here. Okay, I have converted on network event in the avatar to a virtual method, because now on player we are going to extend it, okay? And here we are listening to that event, to the event player bullet shot, okay? And we are retrieving the parameters, identifying that, okay, it belongs to us, this bullet, and we can proceed to shoot the bullet. Okay, if everything is right and we proceed to run the project, first of all, remember to copy the changes. Now run both Unity instances. And shoot in different directions, and notice that the bullets are being dispatched in the direction we want, okay, for one player and for the other player. So as an extra exercises that you could do if you want, this exercise is of medium difficulty. You have to make all the necessary changes for the enemies and the NPCs to consider multiple players, okay? So right now the code is only focused to have one single player, and both the enemies and the NPCs only consider one single player. So make the necessary changes in order for them to consider multiple players. Another exercise of also medium difficulty, use the options that provide Photon in order to add additional parameters in the process of the instantiation in order for the enemy to know about its initial animation at the start. Okay, so this way we can avoid having to ask about the animation that as we have done it. And something that it's extremely hard to do, you would have to rebuild all the existing enemies and NPCs that exist in the level prefabs, okay? And why you should rebuild in all of them? Because you want them to work in network mode, okay? This is an extremely hard exercise. All these three are optional, so feel free to do it.